Hello, Algebra 2 students. So today we're going to continue our study of transformations of quadratic functions, but we're actually going to graph them. So in the previous lesson, we talked about how to describe the movement, like what caused it to translate left or right, up or down, reflect across the x-axis, vertical, compress, or stretch, things like that. So again, this lesson we're going to specifically, take a look at adjusting the table to graph. So again, remember from yesterday, the vertex form of a quadratic function looks like this. F of x equals a times the quantity x minus h squared plus k. So again, your a value tells you, first off, if it's a stretch or compress, and then if it's negative, it's a reflection across the x-axis. Your h value will tell you if you're translating left or right, and your k value will tell you if you're translating up or down. Okay, so going back to our parent function, if we have f of x equals x squared, since our a value out in front is 1, it's positive, so it opens up. Remember, our vertex is x comma k, or I'm sorry, not x comma k, h comma k. There is no h or k in here, so it's going to be at 0, 0. My axis symmetry, remember, is at x equals h, so that would be x equals 0. And the y-intercept doesn't exist in this problem, or I shouldn't say it doesn't exist. The y-intercept, there's no constant at the end of here, so it's going to be at 0, 0. So again, what we're going to do is we're going to use this parent function table to graph each one. So if I would plug in the points, -2, -1, 0, 1, and 2, these are the 5 we're going to start with each time. So if I plug it into the function, -2 squared is always 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So if I graph it, if I graph my points, -2, 4, 1, 2, 3, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So again, it opens up. This is my parabola, my quadratic function. And again, this would be the axis symmetry down the middle here. So again, when we continue doing the other problems, we're going to continue to come back to this parent function table and then adjust it based on what type of transformation occurred. Okay, so we're going to practice some of these. Okay, there's 4 in our notes. We'll kind of see how it goes. So again, if we have f of x equals x plus 3 quantity squared minus 2, remember it looks like a times x minus h squared plus k. So if we think about it in general, this one opens up because the a value would be 1. Okay, your vertex, remember, is h comma k. I need to write that on the side there. So it's going to be at -3 comma -2. Your axis of symmetry is going to be at the line x equals -3. And then if we do our table, so again, our parent function table, -2, -1, 0, 1, and 2, when you plugged it in, when we squared it, we got 4, 1, 0, 1, and 4. That came from the previous page. Now let's talk about what happens here. This plus 3 here means we're going to translate, there we go, left's better, translate left 3. And then here we're going to translate, not up, I'm sorry, down 2. So think about it. If we're going to translate left 3, what is that? Which variable am I affecting? Hopefully you're going to say the x variable. So that means for every x value, since I'm going left 3, I'm going to subtract 3 to every x. So if I was at -2, we're moving it left 3, so it's going to occur at -5. If it was at -1, it's now going to be at -4. 0 is going to move to -3, 1 is going to move to -2, and 2 is going to move to -1. Now if I'm going down 2, down is affecting your y variables. So I'm going to subtract 2 from each y value. I'm going to shift it down. So 4 is now going to be come at 2. 1 will be at -1. 0 will move down to -2. 1 will move to -1, and 4 will move to 2. So if I plot my vertex and then I plot my new points, I should be, again, good to go with my graph here. So my vertex is at -3, -2. That's where my axis of symmetry is also at -3. X equals -3. And if I plot my points, -5, +2, -4, -1. Again, we had the vertex already. -2, -1, and -1, +2. There's my 5 points. And again, I can draw my graph. Okay, so again, what we're going to do is adjust the table to our parent function. Okay, moving on here. If I have f of x equals negative times x minus 4 quantity squared plus 3. Maybe instead of doing it last, let's do this first. So let's talk about the movement here. So this negative out in front means it's going to be a reflection across the x-axis. The -4 here means we're going to translate to the right 4, and the +3 at the end means we're going up 3. So again, let's go through our basics here. So it opens, in this case, down, because it's a negative out in front. Our vertex, remember, is the HK, so it's going to be 4, 3. My axis of symmetry is going to be at x equals 4. Okay, so making my table here. So again, my parent function looks like -2, -1, 0, 1, and 2. And again, when I plugged it into the parent function, it was 4, 1, 0, 1, and 4. So let's talk about adjustments. So if I'm reflecting across the x-axis, which variable is that affecting? Hopefully you're going to say y. So we're going to multiply the y by -1. And then if I'm going right 4, that's affecting my x's. So I'm going to add 4 to each x. And then if I'm going up 3, then we're going to add 3 to the y's. Okay, so let's shift. So for every x, we're going to add 4. So that means this is going to be at 2, 3, 4, 5, and 6. And you always, order of operations tells you should multiply before you add. So 4 times -1 is -4. -4 plus 3 is -1. So for 1 now, 1 times -1 is -1. -1 plus 3 is a +2. 0 times -1 is 0. 0 plus 3 is 3. And then we're back to 1 again. 1 times -1 is -1 plus 3 is 2. And 4 times -1 is -4 plus 3 is -1. So we're going to plot these points along with the vertex and the axis of symmetry. So again, the vertex is at 4, 3, 1, 2, 3. My axis of symmetry, remember, was at x equals 4. Okay, so my points are 2, -1, 3, 2. We already had 4, 3 here. 5, 2, and 6, -1. Notice I have my 5 points. If I draw it in, notice it does open downward. That's what it was supposed to do. And you will always get your 5 points again from your table. Okay, I've got 2 left here for practice. So again, this next one, if I just talk about what these numbers mean, this 2 out in front means it's going to be a vertical stretch. The 1 here means we're going to translate to the right 1, and the -3 means we're going to translate down 3. So again, going through our list here, this one opens up because my a value here is positive. Remember, the vertex is going to be h comma k. So in this case, it's going to be 1 comma -3. My axis of symmetry is going to be at x equals 1. And then going back to my table here. So again, my parent function table is -2, -1, 0, 1, and 2. And again, when you plugged into that parent function of f of x equals x squared, you get 4, 1, 0, 1, and 4. So we're going to adjust. So if it's a vertical stretch of 2, I didn't specify that. Vertical is your y's. So I'm going to take each y and I'm going to multiply it by 2. Translate right 1 means we're going to shift every x to the right 1, which means we're adding 1 to it. And then if we're translating down 3, that's affecting your y's, so then we're going to subtract 3. So for x's first, if I add 1, I'm going to be at -1, 0, 1, 2, and 3. If I multiply each y by 2 first and then subtract 3, so 4 times 2 is 8, 8 minus 3 is 5. 1 times 2 is 2, 2 minus 3 is -1. 0 times 2 is 0, 0 minus 3 is -3. 1 times 2 is 2, 2 minus 3 again is -1, and the same thing with 4. 4 times 2 is 8, 8 minus 3 is 5. So if I plot my vertex, my axis of symmetry, and my points, so again, my vertex is at 1, -3. My axis of symmetry is at x equals 1. And then my points, -1, 5, 1, 2, 3, 4, 5, 0, -1, 1, -3, which I already have, 2, -1, and 3, 5. So notice it's stretched. You see how it got narrower in comparison to the other ones? That's what should happen when it's a vertical stretch. If it's a vertical compress, you're going to flatten out. It's going to get wider. Okay, so the last example that I have is this one. So if we talk about, again, verbally what happens first, the negative out in front means it's a reflection across the x-axis. The 3 means it's a vertical stretch of 3, if we be specific. The +2 here means we're going to translate left 2, and then +6 at the end means up 6. So this one had all of the above happening. It had all the different movement. So again, starting from the beginning, this one opens down because it's negative out in front. The vertex, remember, is h comma k, so it's going to be -2 comma 6. The axis of symmetry is going to be x equals that h value, which is -2. And then again, if we make the table, so we're going to have -4, or I'm sorry, not -4, -2, -1, 0, 1, and 2. And when you plug them in, you get 4, 1, 0, 1, and 4. So if we shift our graph, reflection across the x-axis, that means we're going to adjust the y's. We're going to multiply by -1, actually by -3, because we're stretching it as well. So again, we're going to multiply our y's by -3. A translation of left 2 means we're going to subtract 2 from every x, and then we're going to go up 6, so that means we're going to add 6 onto our y's. So let's do one thing at a time. So if I go left 2 for my x's, I'm going to be at -4, -3, -2, -1, and 0. For my y's, so I'm going to multiply by -3 and then add 6. So 4 times -3 is -12. -12 plus 6 is -6. 1 times -3 is -3. -3 plus 6 is 3. 0 times -3 is 0. 0 plus 6 is 6. And then we're back to the 1 and the 4. Okay, so if I plot my vertex, -2, +6, 1, 2, 3, 4, 5, 6. And then the axis of symmetry is at x equals -2. So there's that. And then if I plot my points, -4, -6, 1, 2, 3, 4, 5, 6. -3, 3, 1, 2, 3. -2, 6. We already have that. -1, 3. Ooh, I'm off a point here. I'm sorry. and 0, -6. 1, 2, 3, 4, 5, 6. Okay, so this point should actually be there, and this point should be here. So if I draw my graph, again, it fits what we talked about. It reflected across the x-axis because it's opening down. It stretched vertically. It got more narrow. And again, we shifted the vertex to the left 2 and up 6. That's where it should occur. Okay, so for today, you're going to be continuing on in your packet with the next worksheet, which should be lesson 9.3, day 2. Again, you're going to graph these quadratic functions in vertex form based on transformations. So it looks like this particular worksheet here. Okay, and then there are a total of 22 problems on that. If you have questions, please let me know.